Good morning, everyone. I, I welcome you all to the session 3 of Track 1 Structural Engineering for the third International Conference on Advances in Civil Engineering. Today we have, in this session, we have 3 keynote speakers and 12 participants are going to present. So first we have our chair and co-chair. First, I'll introduce our chair as well as my co-chair. Uh, the chair for this session is Dr. Kokutla Ramesh, Professor and Head Department of Civil Engineering, Prasad V. Potluri Siddhartha Institute of Technology, Kanuru, Vijayawada. I welcome you, sir. Mr. K. Ramesh, Dr. K. Ramesh, sir, did his BTech from SVH College of Engineering, Machilipatnam during 1989 and MTech from Walchand College of Engineering, Sangli during 1991. And he did his PhD from NIT Warangal during 2003. He started working at Kakatiya Institute of Technology Science, Warangal during 1991 to 2003 and joined Kane University as a professor and HOD in civil engineering department. He worked as a principal for Amra Institute of Engineering and Technology, Satluru, and Sri Vasavi Institute of Engineering Technology, Nandamuru. He is the line during 2010 September to 2012 September as a dean at Lucky Reddy Balreddy College of Engineering. His research specialization is structural engineering. Currently, he is working as a professor and head at PVP Siddhartha, Vijayawada. He also received the Dr. Abdul Kalam Lifetime Achievement National Award from International Institute of Social and Economic Reforms, Bangalore, and Adarsh Vidya Saraswati Rashtriya Puraskara National Award of Excellence from Global Management Council in the year 2019. He is a life member of ISTE and International Center for Fiber Reinforced Concrete Composite. Once again, I welcome to the chair Dr. Kokurla Ramesh. Thank you, sir. Thank you for joining this meeting. And I'm also happy to introduce our co-chair, Dr. Hanuma Kosangi, who is the assistant professor in Department of Civil Engineering, VR Siddhartha, Vijayawada. I welcome you, sir.
Thank you, sir.
I'm very happy to introduce Dr. K. Hanuma Kasangani. He did his BTech from SRKRC Bhimavaram during 2010 and MTech from NIT Surathkal in 2012 and PhD from NIT Warangal in 2019. He started working at NOAA College of Engineering as an assistant professor and joined Vigyan Foundation of Science, Technology, Research as associate professor during the year 2013-14. His research specialization is fiber reinforced composite, functionally graded materials. Currently, he is working as assistant professor, Department of Civil Engineering at VR Siddhartha College, Vijayawada. He received Institute Teaching Assistance as a PhD scholar at NIT Warangal from the Ministry of Human Resource Development. He is academic peer reviewer in structures and buildings, ICE International Journals of Steel Structures, Construction and Building Materials, IEEE Journal. He is a professional member of Indian Concrete Institute. Once again, I welcome you, sir.
Thank you.
Now I hand over the session to co-chair Dr. K. Hanuma, sir. Please go ahead with the introduction of our first keynote speaker, sir. Thank you, sir. Thank you.
Okay, sir. Thank you for this opportunity to introduce a keynote speaker to the participants. So today's keynote speaker is Dr. Sir Ranjit Disanke, Senior Professor, Department of Civil Engineering, University of Perdiniya, Sri Lanka. So next.
Yes, sir.
So thank you, sir. Once again, welcome you, sir. So Professor Ranjit Desainke is a senior professor in civil engineering, University of Pradesh, Sri Lanka, and presently the secretary to the State Ministry of Rural Roads. And sir, screen is not visible.
Yes, sir. Yes, sir. One.
Hello?
1 second, sir. 1 second.
Okay, okay.
1 second, sir. It is.
No problem. You can introduce, sir.
Okay, one second, sir. It was just. Yes, sir. Yes, sir. Please continue, sir. Yes, sir. Please continue, sir.
Okay, sir. So he also served as the secretary to the State Ministry of Urban Development. So, Professor, he was a Fulbright school in USA, indoor fellowship in Australia, and JSSO research fellow in Japan. He was awarded the Youngest Scientist Award in 2007 for excellence in scientific research by the NSTC of Sri Lanka. So he received the overseas prize of the ICE in 2007, UK and the Australian Alumni Excellence Award in 2012. So he has published over 150 papers. He has chaired more than 10 international conferences. He is a fellow of the Institute of Engineers, Sri Lanka, IESL. So he is the chairman of Green Building Council of Sri Lanka, GBCSL, and Civil Engineering Secretarial Committee of Institute of Engineers, Sri Lanka, IESL. Also, he is a vice president of IESL and Chamber of Construction Industry, CCI. So, in private sector, he is the chairman for Lego International Private Limited, ICB Private Limited, Lanka ASC Private Limited, and GA Private Limited. He is chairing the 12th International Conference on Structural Engineering and Construction Management, which will be held at earliest Regency Canada in Sri Lanka in 2021. So once again, we welcome you, sir, and we are very happy to have you, sir.
Okay, thank you, sir. Thank you, Hanma, sir. Ranjit, sir, I'm making you as a presenter, sir. Please continue with your presentation, sir. Dr. Ranjit, sir.
Wait. I'm
Yes, sir.
sharing.
You can, yes, sir. You can share.
Can you see the presentation? Can
Yes,
you
sir.
hear
Yes,
me?
sir.
Yes,
Yes,
sir.
sir. We
Yes,
can
sir.
see that. We can see. You can continue.
Okay, I'll continue the presentation then.
Okay, sir.
Good morning from Sri Lanka. Thank you so much for the invitation. I'm pleased to speak here on the topic of forensic engineering. Let me move my presentation. I just give you the definition of the what is the forensic engineering is. This is activity related to the failure investigation. So, for example, there can be a investigation of sometime material failure, product failure, structural failure, or component. That payload do not operate or function as intended, causing the personal injury or damage to properties. The consequences of failure are dealt with by the law. So that is the situation, because when there is a failure happen, it can be due to the many reason like material, product, component can be null as a failure. This can be complete failure, or sometimes it won't operate as we wanted. So then finally, if you could not come to the settlement, we may have to go for get the assistance from the court of law. So situation like that may happen while you are working as an engineer. And the problem is, once this kind of failure occur, we have so many questions. Some of the questions can only be handled by engineering investigation, whereby we can give the opinion why this happened. So usually failure as like this, these are real failures. So then the owner has a question, can be government, private party, and so forth. They have the why this kind of failure happened, and what is the cost of the failure, then how this happened, and who responsible this one. So this is where we need to go for the structural assessment. So can become as a forensic engineering, forensic analysis. And so this is the whole topic of today's discussion. Then we have to, in order to identify the why, how, and who, these are the some of the questions can be answered by the forensic engineering. So it is this kind of failures are happening almost every day. Good example is if you go with the most recent one. So what I usually do whenever I invite a lecture of this nature, I go to the internet and find out what is the reason biggest failure. So it is yesterday, the Minami building collapse in USA. Just yesterday, you might have heard it. So this is the, just to show you the some
major
clip.
rescue operation is underway in Miami after an apartment block partially collapsed. It's believed that at least one person has died. A 10-year-old boy, though, has been rescued. The local fire service says 80 emergency vehicles were sent to the scene. It's not clear how or why the 12-story residential building, built in 1981 and containing more than 130 units, came down, or indeed how many people were in it at the time. What we do know, though, is it came down overnight in an area called Surfside, just north of Miami Beach. James Reynolds has the latest.
Amid the rubble of the apartment building, fire crews managed to find a young survivor. He's able to climb out himself. In an undamaged section, firefighters take an older resident to safety. No one yet knows how many others may be trapped in the wreckage of the block, which is called Champlain Towers South. It partially collapsed in the middle of the night.
I looked out the window and you couldn't see. I thought it was like a storm or something coming in. And then when the dust cleared, there was the back half of the building, or back 2/3 of the building was gone. It's down to the ground.
It looks like a whole, from the top to bottom, section of the building just collapsed. Crazy. I mean, I think something you've seen in a earthquake or something.
This video was posted by the resident of a nearby hotel. The Miami-Dade Fire Rescue Department has sent more than 80 fire and rescue trucks to the scene.
So by now you will realize what the big damage caused due to the failure of the apartment complex in US. I think right now the records say that nearly 2,000 people has died so far, but the real number is yet to count. So this is the problem. This is where the forensic engineering come. Why this kind of structure collapse? So what is the reason? But before this happened, if you go for the structural health monitoring, you will be able to go for the kind of either modification or the changes or demolition, something would have done. So this is where the structural health, therefore, rather than we more concentrate on the forensic engineering, we must concentrate on structural health monitoring. That means it should be a continuous process. What has happened is we have been in the system of building the high-rise building and so forth during last like 100 years. Now we have the most of the structures has come to a time where it is lifetime has gone, but still we don't care about the structural health monitoring. So it is like almost like a human being. So at the beginning of your life, mostly you don't want to go to and see a doctor. But when you are getting old and older, you need to visit regularly to a doctor. It is very much similar, but in case of human being, people feel that we are getting weaker and we get a lot of the problem and we can't walk and so forth. But what happens is when in the case of structure or the building, they can't express this. But though they sometimes express, again, somebody has to visualize it. It can come as a deflection, cracking, vibration, and so forth. So if you are not going to monitor it, it eventually collapses as you seen there. So that is where I would like to start. But I have collected many failures around the world. I'm not going to explain in detail. I'll show you some of the photographs which you can understand the color. So again, these also again happened in Miami in US, collapse of the very new, the crossing, close to the Miami University. 6 people died, as I remember. So this is another the strategic failure in Bangladesh. Nearly close to 2,200 people died in the apartment. That is the reason behind that. Very very briefly, I explain it. This is where the government industry is booming, so that the owner is getting the more and more jobs. They want to expand. They want to increase the number of people that they, without any assessment, any investigation, he has just gone up, increasing the number of floors. What happened is due to the dead load, it has come down. 100, nearly 2,000 people died on the spot. So that is one of the strategy happened in 2013. So, but if you go back to every year to the history, you may find that there are so many failures around the world every day of the uh, every year. Even if you go back the BCs, like 1780 BCs, the ruler of the Babylonia, there has been the system. If the builder build a house and kill his owner, then the builder shall be put in the death. That means that there were such a rule. That means the failure of structure is not common to today, but it has from the beginning of the civilization, right? But only problem is that we have not taken the correct measure in order to reduce this one. Because even if you go for our engineering curriculum also, we are not much talking about the forensic engineering, structural health monitoring, assessment of structures, and so forth. But of course, that may be okay about 50 years before, but now it is the time has come. You include this kind of new subjects areas into the undergraduate level as well. And of course, the other area that I always want to tell is the inclusion of including the sustainability or sustainable built environment. That is also going to be the very important area that you should teach the student, because of the present day climatic changes and the many issues. Student must aware about the sustainable built environment. So let me go a little bit into the subject of why structure fail. So let me come up with the why the structures are failing. The structures are failing due to the design failure, construction failure, and the extraordinary loading. And there can be a situation not understanding the fundamental behind the structural design. Sometimes we don't understand the structural failure mode. So we design for the different failure mode. Sometimes the prominent failure mode may not be understood. Then of course there are many situations where maintenance and due to the operation, it is maybe the different operation, changing of the player, the the building, original building requirement and so forth. Sometimes it happened due to the material. These are some of the very common reason behind the failure. Sometimes when we are not selecting the proper ground conditions, so there will be a foundation failure. So that happen most of the situation. Sometimes we go for the alteration because we build the building for the school, we end up with the factory. We sometimes move the factory machines and so forth without going for the proper assessment. So these are the reason behind the failure. This is where we need the forensic engineering to identify the responsibilities and cause behind the failure and what action we can take for the future. When you go to the responsibilities, the situation, once there is a failure, nobody take the responsibility. Once the structure completed, everybody would like to say that we are part of this construction, but the one responsibility of this is can be due to our failure. So this is where the forensic engineer have to come and find out who responsible. That is the part of the responsibility of the party. So basically, client or the required opinion by the forensic engineer. Another way that the responsible party, sometimes client itself become responsible. Client may say that, okay, increase the additional flow or not to do this way, you better do this way. You don't have to spend much on the foundation. Sometimes consultant who hired by the client make the mistake without doing the proper job there. And again, the contractor also responsible not doing the proper job. And then there can be a political influence. Sometimes the politician instruct do this way, that way, and it happened in the third world of the Southeast Asia mostly. And there can be a situation due to the disaster. The results will be like you see that the recent failure there, nearly 200 people died, and it ended up with the litigation. We have to go to the court and solve this property damage. Sometimes I have seen some project has been abandoned nearly 10 years. Of course, the definitely delay happened. Definitely, most of the failures extra cost is ignored. Of course, when you go to the cost of the failure, it is like the almost the forensic medicine. You have to find out get the sample and discuss with the relevant parties and so forth and do the investigation. Very much similar to what the forensic engineering. So another one is the I'll go to a very simple example of failure of the very simple bridge that will explain the whole process of how we are going to do this. Say this bridge collapsed in 1991. This is where I started my career as a senior lecturer of University of Peradeniya in Sri Lanka about 23 years before. Then we with my senior professor, Professor M.P. Ranavira, I started studying why this kind of structure. This may be the first incident. My basic degrees are in structural engineering. That may be the first incident where I involved in the failure of the structure. That drive me to do thousands of such failures around the world, mainly in Sri Lanka. So when we understand that the bridge has been originally constructed in 1906 in Kala, where it was a timber deck. It is far away from the Colombo, but later that particular road has been widened. Therefore, this particular bridge is not going to work anymore. Therefore, in 1965, that bridge has brought to a new location called Paragastota. Still, it has been there as a timber brick. But in 1999, the timber deck was replaced by a concrete deck. You have to understand that it has been there from 1906 to 1919. Maybe some repair work has been taken place, but until 1999, it is a timber deck. But 1999, it has been the deck has been changed to a concrete deck. So that is the point. Like it has been like this. So timber deck, vehicle are moving. But the forensic engineering, what we understand that in 1965, that was brought to a new location, and 1990 deck was completed. So what happened is something like this. So there has been failure, as you see there. So then I mean, the people were thinking that is due to the maintenance, some aging. This is because all break. But we did the analysis, we understand that it has been changed to the from the timber deck to concrete deck without doing any assessment. Dead load has been the reason behind this. This is a political decision. Politician has instructed the poor engineer. There is a sound due to timber. Why don't you change it? The engineer who has taken the instruction from the politicians and changed the timber to the concrete. So that is the reason. So that when we do the investigation, we understand in the trust system, we name one member called 17th member, that is the most critical member. We understand the applied load is 1950, but the elastic capacity is in the 1870. It's obvious what has happened there. This is what we learn in first year stress strain analysis of the member. So this is what happened because when the applied load is more than the tensile stress, the eventually it breaks. So when the first member break, eventually load will be transferred, the other member transfer, then the structure may come down. This simply yielding deformation and fracture of the most critical member. Reason behind this failure. So, but we have been handling several similar bridges. This is the one of the bridge. So this bridge has been, again they want to replace, but we did not want to replace, but we did the structural health monitoring, so assessment, and understand what are the weakest members, we strengthen weakest members and repair this bridge. So just to say that what are the lessons that we are taking into the our understanding and do the assessment of this kind of lecture. So this is the you can see that once it is completed, so you will see that there has been a lot of research work done on this area. We have done a lot of big structures and so forth in Sri Lanka. We have been doing during large 25 years. We have written so many books and chapters and done a lot of work in this area. So another interesting structure. It is we have a lot of these structures in Sri Lanka. We call Dagaba stupas. So this has been all stupa. So that was repaired to assume original shape, right? Because so once almost it was completed, it came down as you see there. Right. So then only we started to do for the forensic investigation, right? Collapse of the Dagaba. So where we understand is this is wanted final shape, but presently it is like this one. So this is the Dagaba built by the King Tutugamun, 21 100 years old. So 161 BC. But first attempt was done is 1980, and it fell while, as you saw there, while doing. But there has been another start of the retrofitting, strengthening in 1990, but it's successful and successfully completed. Let me explain how it went, because there had been assessment. Assessment was done, condition survey, material testing, and the analysis was done, and the conclusion come. Just to, I'll give you the not to more detail. So, according to the archaeological requirement, they cannot touch whole structure. They cannot touch the whole structure. They have to do any modification, keeping this as it is. So this is the finite element model, because inside you have the existing rock, earth. So when we do the analysis, we understand that there is a failure. But if the structure is completed with the brick, there of course there will be some places where you get the tension and compression, but it may not fail as you saw in the slide. So that is the reason, because there has been a lot of brick structures, stupas around the country, which has been built with as a solid brick structures. But they also thought that they did not consider about this leave in the inside as it is. So that was the reason why this was colored. By after understanding this one, so the ring beam has been introduced as you see there. So then completion was done, and this is the present situation of the bridge. So you will see that the uh, present situation of the structure. So let me come the some of the findings. Some of the findings are no assessment has been done. Tension dead load is the reason behind this one. So failure of the highway bridges. So this is another failure of the highway bridge. So you will see that the completion is done. First, what they have done is the completion of this kind of metal bridge. Then after that, completed like that in order to provide the bypasses. So collapse of the this one happened. Reason behind is we understand by the forensic engineering. So it was completed in 2007, built 2008 December, and 2009 December other side. So they have made you will see the mistake. They did not build it simultaneously. They built it only one side, they went for the other side. So that was the reason behind this failure, right? Let's see that there have been a lot of cracks appear. Then they wanted to make the retrofitting. So again, they made the same mistake by removing soil one side, right? And not only removing the soil by one side and heap up other side, so that the loading pattern will be completely changed. That caused the structural failure, as you see there, right? So mistake is that they would have there's no anything with the wrong with the structure. Problem with the I mean the filling of the structure. So these are the finding, the improper construction and retrofitting work. So when I was discussing this one, I found a very interesting failure in Shanghai in the internet. I would like to share it because there's similarity of this failure and that failure. So this is the failure. So they have completed this kind of 13 apartment. In one of these apartment, they want to go for they want to go for the garage. So once they go for the, can I come back to? Yeah. Yeah, I will give me a few minutes. So what happened is the load was being transferred to the other side. So that eventually the same day raining was started, as you see there, and building collapse as you see there. So that these two situation is for me the very similar, right? This is the building, that is the bridge, right? You will see that, right? So similarly, these are in a way these are common sense of engineering. These are not engineering that you learn in the textbook as a theory. These are common sense, right? This is the failure. So you will see that the failure, it is the no proper construction, or of course the no, even the common sense has been used there. Let me go to the case study, the forensic engineering and retrofitting. So the case study is I was invited to see a crack of the building. They are not so serious. They just want to me to have a look. So even I did not go there. One of my student or the one of my engineer went and had a look, and he sent me the photograph and said that sir, there are a bending and shear crack due to the self weight. So then what happened? I understand if this is the crack due to the self weight, what will happen when the structure is loaded? This is a heavily loaded structure. Then what I saw that the first shear cracks and the bending crack, major beams due to the self weight of the structure. So during the forensic engineering, we have to go into the detail of material and getting the samples and so forth. Then we did the finite element analysis. The finite element analysis, what we understand is that there is design is incorrect. Low concrete is not the reason for the failure. Then we started strengthening. What you see at there's a shear wall that was not originally. These are our strengthening proportion. You might see the some of the steel, some of the shear, fiber reinforcement polymer, and so forth. These are, of course, our strengthening proposals. Why we have to go for the different kind of, because we don't want to disturb the operation of the building. So you will see that the steel and the fiber reinforcement polymer and concrete has been adapted into the system, and so this is the building. Even they want to add some additional load. Day before yesterday also, I visited this building, and still while this structure being construction, we did a complete assessment of the structure, right? So during the construction, we did the assessment. This is the structure. So we had a online data recording system that was mobilized in order to see the structure. So these are the present day loading. So there are so many load has been dynamic load and the wind load and the temperature and many things are there. But in order to cater, this is how we got our measurements, right? So these are the measurement that we could do. And we developed some situation finite element model in order to see the present situation of the structure time to time. But anyway, we observe some crack later also. But for the during last 8 years, it is properly operating without any doubt. But sometime when they have the bad observation, they will let us to know. We go and do, but they don't do any alteration without our advice. So these are some of the data that I'm not going to use that, but our recommendation was the regular inspection and testing is the way to minimize the risk of the damage of the structure. So this is common for any structure. Also, regular inspection and testing is the way to minimize the risk of the damage of structure. In conclusion, every structural engineer should study on the structural failure. They must use the many failures you should understand. So that is why important of the study in the forensic engineering, right? Failures are more important than the success story. Success story, you don't see the gravity of it, but when you study the failures, you will learn more. And they use the common sense. Most situation, most of the failures are due to the common sense, engineering common sense, like what you see there. In another conclusion, you must say maintenance of the structures is very, very important. Structural health monitoring is equally important. And review of the structure is very, very important. So with this, I would like to come to the last point of any alteration must be reanalyzed because there has been a lot of alteration is being done to the structure, reanalyze of that is very, very important. With that, I would like to conclude my presentation. I have a small problem. Actually, I got the invitation from the Japan, invitation from Japan. I accepted both, but I understand that I have to deliver the two lectures. Other party also calling me because I thought I accept the one, but it seems like I have accepted the two. So these people are calling me to come the Zoom. I would like to, hello, 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 hello. I would like to conclude my lecture.
Thank you, Dr. Ranjit Ditnaike, sir. Thank you.
I'm sorry because it seems like I have accept the one invitation. It seems like there has been the two invitation from India. They are actually calling to get into the link.
Okay, no issues, doctor, no issues.
Sorry about.
Yes.
Yes, sir.
No problem. No.
So thank you, sir. Thank you very much for your presentation, sir.
Thank you. Sorry, I'll go to the next presentation then.
Okay, sir. Thank you, sir.
Okay. Hello? Hello?
Yes, sir.
Hello, sir. Good morning, sir.
Morning.
Sir, can you join, sir? Or any
Yes.
help, sir?
Yeah, I'm joining now.
Yes, sir.
Yeah. Let me